Remember, it's not enough to just graph the thing because you remember a trick. Do the table. If you don't have to work to back it up, it ain't going to count. Because you will get stuff throughout math that if you can't do the table or if you're not willing to, you cannot get the graph. So, training wheels on. Do it right now so you can do it right later. I want to know what you know, not your neighbor knows. Do you want dot book or graph? Because some kids prefer that to that.
Yeah, I'll just do graph.
There you go. Shoot. Okay. Prime example of where the table skill comes in. Just this morning, I had pre-calc graphing by table, except they were doing fifth order polynomials. Hi.
Can I know which numbers to use for the
You choose whatever numbers you want to, but we said that these specific ones in this area are probably a good starting place. All right. Yo!
Did we get a new packet last time?
We did not because I thought I had it printed out, but I didn't. But now I have one. You'll get it today. I got a big honker. $1. That's what they are at Walmart. So I just bought a book, so it's a brick of them, so that it's easier for kids to do. So throw it in here, same as usual. Oop.
Can I just write down the points that I plotted? Or do I have to do this whole freaking thing? Or does that count as a chart?
It's reverse engineered, but you made the table. Have fun with nonlinear ones, but yes, that'll count.
Is that what she was asking if you have to continue all the way down? Or will that be
Well, I showed everyone a way that you can get that table cheater method, where you don't have to do all the hard work yourself. You just type it on the calculator. So if you got the table to back it up, cool. Okay, looks like the whole good chunk here are done. Is anyone still rolling? See, there's a skill to it where you can either do cheater tables, where you don't got much work shown because you're letting all the calculator do the work for you. Perfectly legal. Or you do it for realsies, where you actually put 3/2 times a thing minus 7. Okay? Either one of these ways works. Option 1 says, I'm going to do the work. This is how I graph things when I have no freaking clue how to graph them. And that goes all the way up through, I kid you not, halfway through pre-calc, when we first develop our sinusoidal functions. They start with a table. Now we learn the tricks for it afterwards, and then you don't have to. But the easiest way is to start right smack in the middle of the graph with integers. Sometimes those values work, sometimes they don't. And here's what I mean by work. Some of them will give you numbers you don't like. It's still a number, you just don't like it. For example, negative 9/2 minus 7? Ew. So negative 9/2 minus 14/2 is negative 23/2 or negative 11.5. It's not even on my graph. And then 3/2 by negative 2 minus 7, I get a negative 6. No, sorry, negative 3 minus 7 is negative 10. Okay, that one ended up better. I think we just briefly touched on this last time, but there was a trick to it. And this is why I want you to have the table. If you have a denominator, if I'm going to be taking something halves times a number, then how about I just use things that are multiples of 2, so I don't have fractions. Instead of doing this, what if I specifically pick numbers that come out clean, that come out as integers? What if I picked negative 4, negative 2, 0, 2, 4? Because now they're all going to come out as nice numbers. 3/2 by negative 4 minus 7. Like so. Getting. I swear that's a 4. It just looks like trash. Negative 6 minus 7, negative 13. Get a negative 6. Wait, back up. Negative 3 minus is negative 10. Getting a negative 7. Getting a negative 4. Getting a negative 1. If I've got enough points, I can plot them. I just need to have enough that are on my graph, and that's it. I see a 2, negative 4, and a 4, negative 1. 2, negative 4. 4, negative 1. 2 points makes a line, right? It's actually a geometry axiom that you'll do at the very, very beginning of geometry. I've got enough for my graph. Get my straight edge. Connect the dots. I'm good to go. Said this is one way. Towards the end of class, when some of you were already packing up, so you probably didn't even write it on your paper, I said, yeah, we don't have to show all this work because we got a calculator that can do all the work for us. I can just rewrite this over and over, typey, say 3/2, 3/2 times a thing, minus 7. Bonk, hit the thing. highlight it, switch it over to -2. Highlight it. Where's 0? Enter. Highlight it. And then I can just write those down in my table. I'd said I prefer that you use your resources. You have to know how to do the table. That doesn't mean that I'm going to require you to write down every inch of it every time. So that's one way to get them. If you get good with your calculators, maybe some of us can start to recognize things like, get out of here. 3, 2. Maybe some of us know the tricks of the trade where we can just get the table. Okay. In fact, this is how we do it once we hit Algebra 2, Pre-Calc, and beyond, is we say, look, you have to graph it by table. That is the only way you can graph this function. But how you get the table, well, you can use your resources for that. Okay? So whether you did it that way or this way, doesn't matter. You got the table to back it up, you should have the points. Now, if I were to take this and maybe go by 2s, so I see a little more of it, then it looks something like this. 2, 4, 6, 7, 5, 2, 3, or 2, like that. Okay, so it all depends. But you should have some of the points. I'm guessing none of us went down here. -2, -10, 0, -7, 2, 4, 6, or -4, -1, 2. Okay, you should have some of those points. At least 2 of those points. Now, granted, you shouldn't have only done 2 points in your table, but at least 2 of those points should be somewhere on your table. Did you make the table? Do you have the correct values? Did you plot the correct points? Did you connect the dots? Did you do something silly? Like, I did all of that perfectly, but I thought it was +7. So everything that I have is wrong. I did all of this, but I didn't use parentheses on my 3/2. And then it monkeyed with things. Okay? What out of 5? Now you had a lot of time. Come on now. There we go. Yeah. You had a lot of time. You have had 1, 2, 3, 4, 94.5 hours. I didn't have anyone ask questions that I remember. Maybe someone came in during Spartan time yesterday. Oh. Talk to me, Goose.
Explain 23.
23? Okay. What is this? Simplified discrete. Okay. So that was something that I said, don't worry about the continuous or discrete thing. Like, don't worry about that. We're talking about that today. That's the very first thing we pick up with. But can you graph it? If the cost is 5 plus 9 times p, then I make a table. It says, this is how many pizzas I'm going to order. 5 plus 9p is how much it will cost. Well, how many pizzas are you able to order? Can I order -2 pizzas?
No.
No. If you really wanted to be facetious, you could order 0 pizzas and just pay $5 for them to come to your house and laugh at them. Right? 5 plus 9 by 0 is 5. I'm going to order no pizzas. I'm just going to pay a delivery charge for you to come over here. Now, you can't actually do that. They won't let you do that. However, if you wanted to order a 20-ounce bottle of pop from Domino's and then put delivery on there, you could. Just saying. Don't do that. That's how you like stalk drivers and get creepy. But I could order 1 pizza, 2 pizzas, 3 pizzas, 4 pizzas, 5 pizzas, right? Well, put a 1 in there. 5 plus 9 by 1. Well, 9 plus 5, that doesn't even look like a 9, I swear. I could say 5 plus 9 by 2. 5 plus 9 by 3. 18 plus 5. 27 plus 5. And you start to see the pattern, right? You're just adding 9 every time. So, graph your function. Label how many pizzas are you ordering? I would suggest not going past 10. And then plot your points. Where this is your cost. Okay? But you need to have the table to figure out, like, where it's going to be. Yes, ma'am.
Would you number
21, right above that. Similar deal. The height in inches of 20-ounce bottle of juice depends on the amount of juice in the drink. Makes sense. Got a bottle, amount of drink, height. Okay. The situation is represented by this function rule. So, same thing. I probably can't have 0 ounces of juice. Well, I can have 0, then the height is 0. But let's do the J is the juices that you have drank in it. And your height is the amount left. Height. Drew. So 6 minus 0.3 J. Reading the problem, what's the most amount of juice that could have been in there?
20 ounces.
It's a 20-ounce bottle. Okay? So maybe my table is actually going to work backwards. I'll start with 20 ounces. And then I'll just keep drinking juice. Now, do you want to go down 1 ounce, 1 ounce, 1 ounce, 1 ounce, 1 ounce, 1 ounce? Or maybe you're one of those gluggers. Like, gulp, gulp. My wife says that I drink things too loud. Okay. Maybe I do 20, 16, 12, 8, 4, 0. Big glug. Plug those into J and get the heights. And then again, you'll have that graph where this is ounces of juice left. This is the height of the, the container bottle in inches. So plug 20 in, find your H. Plug 16 in, find your H.
I think the
Plot points.
problem that I was having is I was by 1 ounce, and the difference between was like 6.9 to 6.6.
Uh-huh.
So I'm just like, I was having a
Because
hard time graphing it.
because in the equation, for every ounce of juice that you're drinking, the height is only going down 0.3 inches. Think about a sip. It didn't move much. Glug, 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 glug. It moved.
Yeah. I'm just curious, how
Yep.
do you, I mean, how do you
Experience.
graph something to so super close together?
You ballpark it throughout the boxes. So if it's going down 0.3 of an inch every time,
Yeah.
maybe I make every one of my boxes worth 0.3 of an inch. But if I do that, 0.3 of an inch all the way up to 20 inches, that's going to be a crap load of boxes.
Mhm.
Instead, maybe it's all the way up to, what, 6 inches? Oh, maybe I just go by 0.5s and then I guesstimate where the point is in the box. That's part of what we did last time and what we're going to be doing over the next couple sections is every now and then we're going to get these word problems and it's a matter of choosing the appropriate scale. I'm not joking when I say that I get kids into Algebra 1, into Geometry, Algebra 2, usually they don't make it to pre-calc by this point, who can't make an appropriate scale. They don't know, well, if I go from 20 to 0, what's the appropriate scale? Did they even recognize that the most you could have is 20 ounces? Or did they just start at 0 and go to 100? Did they start at 0 and go to 10, not even realizing that's not all of the bottle? So making the appropriate scale is kind of what we're working on right now for that exact reason. I don't want to have a really tiny graph that has nothing on it. I don't want to have a gigantic graph that's overkill. You got to find the right flavor. You know? Taste before you dump kind of thing. Not take a dump. When you get your food, right? You taste it before you go dumping more salt and pepper on it. Otherwise, you end up tasting what is essentially pork rinds and salt lick. Yeah. Okay. So, again, I didn't tell you to do the discrete or continuous on here because we're going to start there. But to start there, y'all are going to have to fix the copier's problem. Here's what we mean by that. The copier decided to collate. Okay, what that means is that it gave me 24 pages of the last page. And then it gave me 24 pages of the next page. And then 24 pages of the next page. It didn't put them together. So, I would like you to take one, pass them on. Take one, and pass them on. Just send it all the way around the room. Okay? Because the copier did not, it was not cooperative. We'll say that. Okay, take one, pass them on. Take one, pass them on. And take one, pass them on. Hopefully you're all keeping them in order along the way. Just make your pile. Just in the pile, in the order that you got them, and then staple them when we're done. Take one, pass them on. Whichever you prefer. Send it on down. Yes or no? If you don't want hole punch, if you don't use that, then send it on down. So you should have your pile of your, whatever, 6 pages or so. Okay. Right, arithmetic sequences was the last one. Thing. Don't. Because they're all out of order now. Because they were just piled up on you. There you go. And then this goes on top of the stack. Goes on top of the stack. It's amazing what little conveniences there are, like print it in the order I told you to. You're just supposed to send the stapler around the same as always. The other ones. Okay. So, at the front of it, you have the stuff that we went through last time. You do not need to copy anything onto it. If you're gone last time, this would be wonderful for you to do instead. We got through a couple of examples by table, a couple of examples by table, a couple of examples by table, and then we did not quite get to that last part. So, y'all find that, start there. Okay. Oh boy, this doesn't take this long. All right, y'all figure out your hot potato with the stapler. I should probably do tenants. Yeah, so them. We had a full house, didn't we? Yeah, we did. Cool. Okay, I saw a Levi, Amy, Noah, Bailey, T's out, Dominic's here, Asher's back, Ava's out, Tom's here, Killian's here, Gianna's out, Aiden's here, Grace's here, Kayla's here, Sayla's here, Joe's here, Maddie's here, Preston's here, Peyton's here. Cool. All right. We're all caught up. We're all ready to go. Okay. Dominic wants to order more pizza. Is Dominic going to be able to buy 3.87 pizzas?
No. Like, cut me a couple slices.
Like, it doesn't make sense, right? You can't just do that. What if you're talking about, have you ever heard the statistic, like the typical American family has 2.18 children? Like, what does that mean? Is that like 2 kids and a fur baby? You know, like a Yorkie or something? Okay. That's the difference between continuous and discrete. Continuous means I can put any x that I want in there. My input variable, I can put whatever I want in there. I can buy 14.28539 pounds of trail mix. Right? Like, I can exchange an almond for an M&M to tweak the weight just a little bit. So I can do that. That's called continuous. It's continuous, meaning you never pick up your pencil. The graph is straight through. It continues no matter what. Discrete graph. Discrete means it has very distinct income or input-output pairs. I can buy this many couches. I can't go to Furniture Row in Rapid and buy 4.31 couches. And you always get that pedantic kid who's like, well, yeah, you can. That's kind of like the footrest, right? Like, shut up. Okay? No. Okay? You can't buy a portion of a thing. I can't make a portion of a thing. I can't have, if it's not possible to have a portion of an item, a portion of your input value, that's called discrete. You just make dots. You never connect the dots. So, before we get rolling, please tell me, do you know how to table? Not, I learned the trick. I know what slope-intercept form is. I'm just going to count dots. Do you understand how to use a table for when they're nonlinear? What happens when we flip 3-4 slides down the road and now it's x cubed over 5 minus 17 thirds? Okay? If you don't know how to run the table, that's going to hurt. So, boy, that looks creepy in inverted colors. It's like, oh, the... It is!
Oh no.
You're completely right. Or no, it's Santa. Alright, so anyway. I swear it looks less creepy in your book. Okay? Cheese. This textbook publisher has a thing for cheese. I found a word problem about cheese and graphs in every single one of their books. They just got a thing for cheese. Local cheesemaker, if you know how it's actually made, like it is dairy product that has been like curdled, basically. It's not like you go milk a particular kind of cow and out comes string cheese. So you actually make the cheese that's processed. And it says the amount of milk needed to make the cheese at the price which he sells the cheese are shown. Write a function for each situation. Graph each function. Is the graph continuous or discrete? So if I'm going to say 1 gallon of milk makes 16 ounces of cheddar cheese, I'll come down here, I'll make a table. Now that table, I'm going to let the work be done by my calculator. My input is going to be how much milk do I have. My output is going to be how much cheese do I make. So label it. What is it, gallons of milk? And this is how many what cheese? Ounces. Okay. So just like we were doing before, does it make sense that I can have -2 gallons of milk? No. So where should I start my table? Okay, start at 0 because I could have no milk makes no cheese. Okay, start there. And then start filling in the table. And this one we can do by mental math or grab a calculator, I don't care. If I have 1 gallon of milk, how much cheese does that make? Okay, so what's going to happen when I do 2, 3, 4, 5, 6 gallons of milk? Go by 16s. Can you count by 16s? 16, 48, 64, 80, 96. All right. Now, the boxes that I have here, what, about 10 or 12 in each direction? What should I go by for a scale? In fact, I would grab that straight edge and maybe make my L graph, because I know that this thing is going to not go to negative land. I'll just do that so I got room to write. What's a reasonable scale? For M's. For M's. My x-axis, just go by ones. Okay, don't overthink it. We're going to say 1, 2, 3. Okay. Now, I could take the cheater way out and just make each of these boxes 16. Right? I want to see how you do with estimation, specifically because we had that issue with one of our problems in our homework. How do I make it go down 0.3 every time? So what if I just said go by tens? Plot points. And say at 0, 0, at 116, so about halfway, 232, just above the 30 mark, 348, just under the 50 mark, 464, about halfway between, 580, right on the nose, 696, about halfway in between. If you estimated your stuff correctly, you should now be able to put a straight edge on there and it lines up. Okay? My question for you, whether this is continuous or not, if Papa Smurf here is making cheese, does he only have to do 1 gallon at a time? Or is he able to do 1.5 gallons? Can he do 1 gallon and 1 pint? He can do anywhere in between, right? It's just however much milk he's pouring in. So this graph would be continuous. And I'll connect the dots to say that. Continuous because I can just keep pouring in a little bit, a little bit, a little bit. Okay? Like, who's been making mac and cheese, hamburger helper at the stove, and you look at it, you mix it around, and you're like, splash. Just got to put that little extra splash in there, right? Looks a little too sticky. Okay? On the other hand, you have each wheel of cheese costs $9. Make a table. You say, if I sell this many wheels, I make this much. What do you want to use for money? His profit, his just the dollar sign itself. I don't want to use that as a variable though. M just for money. All right. W and M. All right, what's the least amount of wheels of cheese that he can sell? 0. He will make no money. And then if he sells 1, 2, 3, 4, 5, 6, 7, on and on and on. So I'm going to say this is wheels of cheese sold. And this will be my earnings in money. All right. Well, if he sells 1 wheel of cheese, what's he making? 2 wheels. And then just count by 9s, right? 27, 36, 45, 54, 63, 72. So what would be a reasonable scale for me to go by for my X and Y axis? Boy, that's not even a straight line. What should I go by for my X axis? W. Who knows? Okay, so we're going to say by 1, 2, 3, 4, 5, 6, 7. And moolah. 10s again. Looks all right. 10, 20, 30, 40, 50, 60, 70, 80, 90, Hondo, 110. And then in there we will plot points. 0, 1, 9, 2, 18, 3, 27, 4, 36, 5, 45, 6, 54, 7, 63, 8, 72, and then I could keep going. 81, 90. The question is, he's making wheels of cheese. Can he sell 1.385 wheels of cheese at $9 a piece? No. Now, you start to get into unit price where maybe he could cut it up, maybe he could crumble off a chunk, maybe he could just samurai hack through a big wheel of cheese and then weigh it and go by unit weight. But this is called discrete. What happens if part of the process of making the cheese is putting them in a package so that they can get that crusty layer on it? Y'all know, like, actual cheese, not store-bought cheese slices. They're supposed to have that kind of white frosted stuff on the outside and get kind of funky. The inside is the good stuff. The outside is kind of funky. Like real, actual homemade cheeses. So, but the idea is continuous or discrete. You should be able to identify just from a word problem context whether this is discrete or not. Okay? I do not connect the dots when it's discrete. You tell me, for each of these, is it continuous or discrete? You should be able to argue your reasoning. Perhaps with your neighbor. Go! Can I do a part of thing? That's the question.
Technically.
Okay. Now again, you don't want to get too pedantic about it. You know, you don't want to argue the little bits. Like,
I'm really confused on this.
we'll just, okay.
I'm guessing though, because
So, you're probably overthinking it is the issue, okay? The amount of water in a wading pool in gallons depends on the time that it was being filled. So, do you have to turn it on for a minute stop, 2 minutes stop, 3 minutes stop, or could you have it on for 3 minutes and 40 seconds? So that's continuous. Whereas the cost of baseball tickets, can you buy 2.8 tickets? No. So it's discrete. That's it.
Okay, and
must have changed this discrete. Okay.
That's it.
Okay, that makes sense now.
Okay. It's just about, can you get a portion of this thing? First one, what do you think? Continuous. I can turn that water on for as long as I want, turn it off whenever I want. I can have it run for 15 minutes, 41.8 seconds. No problem. Okay? But the baseball tickets, on the other hand, I can't buy 3.1 tickets. Okay? Maybe I want to buy 3.1 tickets because I'm going to buy one for myself. I'm going to buy one for Maddie. I'm going to buy one for Killian. And I only want Grace to be with us for the first inning. After that, she has to go away. Like you can't do that, right? You have to buy an entire ticket or not. So that is discrete. That's it. It's just making sure that you've seen those words before. There's a lot of stuff that occurs in Algebra 1, that's a basis of things later on in math, and kids act like they've never seen it or heard it before. This is one of them. You look further in your packet here, you probably all saw one of the lessons was arithmetic series. You might not see arithmetic series again until chapter 10 of pre-calculus. Okay? But you're going to see it again. And if I try showing my pre-calc kids the formula, they're like, yeah, I've never seen this before. Yeah, you did. It was just 4 or 5 years ago. Okay? Nonlinear. Now we want that table. See, because if you try to do, well, I know the trick. It's down 4, slope is 1, right? So I'm just going to go up 1 over 1. But it's absolute value, so something positive, I'll just move the whole thing up here. No, it doesn't work that way. Okay? We need each of these as a table. Like so. And tell you the magic numbers that we usually toss in the middle of these tables, it's usually numbers right smack in the middle of the graph. You'll choose numbers like -3, -2, -1, 0, 1, 2, 3. Sometimes those numbers won't work out for us. Like when we had that fraction, we probably should use even numbers because it had a denominator of 2. Sometimes we'll get a graph where part of it doesn't even show up. I want to be kind of in the middle by the origin, positive and negative, because who knows what's about to happen. So, if, you know what? Yeah, I want more. No, I'm going to let us make the mistake. Okay, what is -3 minus 4?
7.
Absolute value. 7, right? It's 7 away from 0. If I plug in -2, -2 minus 4?
6.
-6, and then absolute value. So you might be tempted to do this. If you did, you wouldn't be wrong. Okay, go ahead and make those dots. Now, if I saw that on my table, if I saw that on my graph, my first instinct is going to be just connect the dots, it's a line. It's wrong, very wrong. In fact, this is nonlinear. What happens when I extend this table down? Here, go there. I want us to see what happens. Stick a 4 in there. 4 minus 4 is 0. Absolute value of 0 is still 0. Stick a 5 in there. 5 minus 4 is 1. Absolute value of 1 is 1. Absolute value of 1. How far away from 0 is 1? Put a 6 in there. 6 minus 4 is 2. How far away from 0 is 2? Put a 7 in. Put an 8 in. A 9 in. And what happens is it turns out that this thing starts bouncing off. In fact, the more points I do, the more I'm likely to see the rest of the graph. So if I just run with, I know this trick for slope-intercept, that's great for a linear equation. If I say, I know what an absolute value is, it's just everything's positive, so I'm just going to only plot positive numbers. Careful. Run through the table. Now you notice we did the normal, like this is considered standard addition. If you're given a big honking graph like this, I'd recommend spreading it out. Instead of this entire table going by ones, maybe instead I say x and y and I'm going to go maybe -8, -6, -4, -2, 0, 2, 4, 6, 8, and see if I can see a little more to it. And I get 0, 2, 4. Okay. You are going to do problems where you do the table, you get partway through the table and it doesn't even show up on your graph. That means you have to pick different numbers. You're going to do table problems like this where you tried numbers, they worked, I got thing, I put thing on graph, and then it turns out you're wrong because you didn't go far enough. Because later in the graph it had a different feature to it. What happens when it's a parabola? A cubic? A fifth root? What happens when you see your first step function? If we don't have the table to back it up, it's going to cause a problem. Okay? A good way to remember that is this had absolute value on it, so ask yourself what you know about absolute value before you start. What is absolute value? How far it is away from 0. Whenever I do that, I always end up with positive numbers. So I need to know that whatever I do at the end of this, I probably need to have a positive result. So if I just ran with start at -4 and head off, well then that is absolute value of x minus 4, not absolute value of x minus 4. That changes things. That's okay, leave that on there. So we got one over here. Do the actual problem. because I wrote it down wrong. What's different now that the negative 4 is outside of the absolute value? Fill in the table. Put it also on the same graph. Okay, so just right next to that, also an A, also on the same graph. How is this different now that the negative 4 is outside of the absolute value? What changes? Plug numbers in. Plug in probably negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8. Well, unfortunately, some of them you can't. You just have to know that it's positive whatever it was in there. But Casios usually surprise me. There you go. Abs.
Okay.
So shift abs. Okay. Said most of you should only need a scientific calculator for high school. Okay. You should have absolute value in there too. I always forget because I always switch over for those other functions. Where are you? Math. Yep. Okay. So yours is if you hit math, go over to different types of numbers, absolute value. Okay. Math abs. Amy's was shift abs. Okay. So if I'm plugging in negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8, each one of these, absolute value of it is its positive version, right? Absolute value of 8, 8. Absolute value negative 8, 8. Minus 4. 8 minus 4. 6 minus 4. 4 minus 4. 2 minus 4. 0 minus 4. 2 minus 4. Oh, hey, there it is. So I get, ding, put all those in the wrong spot. Get out of here. That'll be a vertex of a absolute value function. I'm going to go from there over 2, 2, 2, 2, 2, 2, 2, 2. So say it's a very similar graph, it's just somewhere else as a vertex. Okay, can you do it with x squared? I hope you know how to square stuff. X squared plus 1, no parentheses. What numbers do you want to pick? It does not matter. Start somewhere in the middle. Negative 3, negative 2, negative 1. Okay. What's negative 3 squared?
9.
Positive or negative?
Positive.
Yes, negative by negative, right? So 9 plus 1 is 10. What's negative 2 squared? 4 plus 1. 1 squared, negative 1 squared. Plus 1. 0 squared, plus 1. 1 squared, plus 1 is 2, 5, 10. Okay? So plot your points and see what this thing looks like. Connect the dots. Ever pulled a UE to an 80?
That sounds like a very bad idea.
It is. The chicken brake in my car didn't work in high school, so I'd mess with people. You ever done a UE on the interstate to an 80? Then you just twitch the wheel a little bit. It looks like a U. It is specifically a quadratic function, and this is called a parabola. And believe you me, you're going to see a lot of them in high school. Okay? Yes.
Do you connect the points or do you leave them separate?
We connect the dots.
Why?
Because this is a continuous function. I don't have to put 0, 1, 2 in there. Couldn't I have put 0.5? Couldn't I have put 1.89? I could put any x I want in there. So I connect the dots to show it's not just these points, but also everything in between. Yes. Parabola.
So, the discrete, does that just have to do with like word problems?
Yes. You hit the nail on the head right there. The word problems can be continuous or discrete. But just graph this equation is always continuous. In fact, you go far enough in math, you're going to get to these in, say, chapter 5 of Algebra 2. You're talking about polynomials. Turns out, by definition, they're continuous for all real numbers. They have to be. So, can you find all the values that come out of a table, no matter what the function looks like? If I just give you random crap, you know how to perform order of operations. No. If you know how to do order of operations, you can fill in a table. So, don't worry about the ones at the bottom. We'll talk about that afterwards. I want you to try this one. It is nonlinear, and it does not look like any of the graphs that you have done yet. Go! The got it 4 at the top. Don't worry about the thumbs down the bottom. Pick a number, put it in for x. Figure out what it is. Pick another number, put it in for x. Find out what it is. I tell you, depending which points you choose, you might get some really big numbers. So you have the right numbers there, but then +1 to all of them. Remember, if you can't find an exponent button, you can always go old school. This times this times this. And if you do it right, when you're done, it should look like 1/2 of a DNA helix. Okay, this is not right. This is not the final product. It's close. It's very close. Okay. If I plug in, -3 cubed is 27. Negative. -2 cubed is 8. Negative, because it is triple negative. -1, 0, 1, 8, 27. But then I have to add 1 on all of them. So it's not -27, it's -26. It's not -8, it's -7. It's not -1, it's 0. 1. Not 8, it's 9. Oops, missed one. T. And then 9 is 28. Okay. So it takes this whole honking graph. Maybe you remember this concept from middle school. You're going to see it again in geometry. You're going to beat the living crap out of it in Algebra 2, called a transformation. A transformation is when I take a parent function and I do something to it. In this case, slide it up 1. It's called the translation. I translate from one side to the other. You remember doing this with figures in middle school? Like, here's a triangle, move it 3 units right, 2 units down. Okay, reflect it, doing that kind of stuff. Okay, you can do that with functions too. And this one happens to be, take the cubic function, move it up 1. Now you don't have to know that. I'm just giving you a little preview. I can just dump this in my calculator. Okay, There's nothing wrong with getting my calculator and saying parenthesis thing cubed plus, get out of here, plus 1. Womp. Womp. Just keep doing that instead. Now, when I said these numbers could get really big really fast, here's what I mean. What happens if you had gone out to nothing major, maybe 6? What happens if I went out to 8? Womp womp. Okay. Have you heard of your problems increasing exponentially? Things got exponentially worse. This is exponentially larger because exponents move numbers very fast, much more than multiplying. The same thing as multiplying by 5 is more powerful than adding by 5. Well, taking something to a 5th power is even worse. Okay, so that one would have run off-road real quick. Show me honesty thumbs. Can you graph by table when it's not a line? I'm good. I look at one of those, I'm like, you should probably do one more to be safe, or I am so lost. Okay? It's a Y that got cut off. Okay? Okay, so definitely need to do at least one more. But we're probably going to do both. Let's start with this guy. Okay? And, like Amy pointed out, it's not a V. It's a Y that got his shins blown off in Nam. Okay? It's a King of the Hill reference. I haven't watched it since I was probably 19. I sure thought it was funny in high school, though. Okay, same thing, make a table. Start right smack in the middle of the graph. Use a calculator to do the work for you. Start with -3, -2, -1, 0, 1, 2, 3. If you've got enough to see what looks like the entirety of a non-linear function, you're good to go. If you don't see it when you're done, that means you need to add more points on either side. You know, there is, again, nothing wrong with using your calculator to type. There's nothing wrong with doing that over and over and over to get the table for you. I hope you can do the arithmetic. My job isn't to teach you the arithmetic. It's to do the algebra. I'm willing to take time with this because I cannot stress enough. I have no freaking clue how to graph a thing, so I'm going to graph it by table. That is your fallback option for the next, 3 years. Now, you're going to learn a lot of tips and tricks over the next few years about how to graph things. I do not have to do it by table all the time. God, no. But if at some point you're going to have to change the tire on your car by hand, you should probably know how to change the tire on your car by hand. Okay? That's what we're doing right now. We're practicing the fallback option. Bunch of you are just getting your licenses for the first time now, maybe in driver's ed as we speak. Do you know how to change a tire by hand? Do you know where your spare tire is? Have you ever worked a scissor jack before? Okay? Like, it's just something that everyone should know. This is something everyone should know. -3 squared is what? No! Positive or negative? You sure? Okay. 9 minus 3 is, Zeke's, -2 squared. Minus 3. -1 squared. Minus 3. 0 squared. Minus 3. 1 squared. Minus 3. Minus 3. Not what... Do what I'm thinking, not what am I saying. Disconnect. Okay. 2 squared is 4. 4 minus 3 is... No. Is 6. And you see that pattern? Well, that pattern is because the axis symmetry for this thing happens to be on the y-axis. Doesn't always happen that way. So, I go back 3, up 6. I'm willing to go a little off-road. Back 2, up 1. Back 1, down 2. Down 3. Womp, womp, womp. Connect the dots. Try not to suck. I got myself parabola. Okay. This is your fallback option. This is the nuclear option. This is... I'm not hunting for meat. I'm hunting just to get it off my property because it's killing my stuff. I can go hunt with a 50 cal. Burger. Okay. Got the job done. This is your nuclear option. This is what you do when you are stuck. Can you do it? Make a table, plot the points. Now this had an absolute value in it. Look at the other problems. What should this look like by the time I'm done? Should it be a U? Should it be that snaky thing like a cubic? Or is it going to be a V? Gotta have the table first. Hey, I don't got the table up there, but that's what it should look like by the end. So, can you table? That's it. That's the end of the lesson. Can you table? Okay, you got the note packet for the rest of it, but today was end of day 5. When you come in on Thursday, review and quiz. Okay? On Thursday, you will turn in your notes, your notebook or binder, or wherever you have your assignments and daily quizzes. It doesn't have to be overkill. You can just have, this is my notebook, put my notes in there, flop, throw it on the counter. Okay, it just has to be organized enough that I know what's going on. Yes, ma'am.
Can you post the solutions so that we can check it before we can?
Not tonight. If I get time for it, I get time for it.